Hi everyone, I'm Thibaut Saunier. I've been developing and maintaining GStreamer since 2010, and I wrote a big part of the video editing stack. I'm going to present what is going on in and around video editing with GStreamer. So the agenda is simple. I will start with the presentation, giving a very quick overview of the video editing stack in GStreamer. Then I'm going to present the latest development and status. And to finish, I will present two GS-based projects that run in the real world and explain how they push the limits of the framework and force us to fill some remaining gaps. So video editing with GStreamer, just a quick overview first. In GS, we have two levels of abstraction. The first one is responsible to create pipeline on the fly, depending on the timeline layout. That's what we call NLE. So we have NLE composition, which is responsible for plugging the elements together. And NLE stands for nonlinear engine. The second one, which wraps NLE and offers a much higher API, is the libjs. So the main feature of that second layer, it's a C library. It's introspectable, so you can use it in Rust, in Python, etc. Most people these days just use it in Rust, people I know at least. The API is pretty high level, and you can write a simple video editing application quite easily with it. But it's also very flexible, and we can build full-fledged video editing software also. GS also exposes the GS launch tool, which is a pretty powerful CLI with a syntax that allows you to describe timelines, but it's also very useful to just transfer code files and things like that. In terms of feature set, I think it's quite comparable to what the FFmpeg CLI provides. It has some more features, it's lacking some other features, but all in all, it's somehow comparable, I think. Also, GS being part of the GStreamer ecosystem, it has the huge advantage of bringing all the plugins that are developed by the community to the editing and post-production world. So that's a very good benefit. So just an example, while in post-production, it's not common to use fragmented stream as input sources. With GS, it's just working because we have everything and you can reuse everything. And to provide like video editing services as web services, which is something that people do these days, it actually makes a lot of sense because a lot of content is like a dash stream, a TLS stream, etc. In the recent past, we have ensured that this works fine. It implied moving away from decode bin 2 and start using decode bin 3 for everything. Actually, that was done part of a bigger rework that we have been designing for 2 years. And it was just a nice advantage, but yeah, all the pieces fitted together. So that other plan grew because of some performances issue that we had. Basically, with the design, we had a problem seeking and playing by, like seeking smoothly and playing back timelines with very short clips. They were not like very smooth because of extra work that we were doing and that we wanted to avoid, and also making sure that we try to prepare things in advance. I will explain that a bit more. Last year, I started explaining a bit that because we were starting that work around the implementation of UI decode pool source. It allows preparing the neighbor clips. I will explain a bit more with that also again this year, but how it has evolved and what other problems that we were not targeting at first are now solved thanks to that same design. So basically, before, the goal was really to announce the scrub seeking experience so that when people scrub in the timeline, it's just really smooth. But yeah, there is also that other issue that when you have a timeline with very short clips, typically that happens when doing cut to the beat of a song, like very small, short clips in the timeline. In that case, well, because of how this was implemented at the lower level. So in NLE composition, we are just not able to do a proper playback with these kind of timelines, even on powerful machine, even with fully array accelerated pipelines. And this is something that UI decode pool source help us with also. So a quick explanation of what UI decode pool source is. Basically, it's just a subclass of the base source written in Rust, and it has underlying decoder pipeline. The decoding, all the decoding happens in the different pipelines, and the pipeline can be prepared in the background, even if the source element that is going to use it is in null or in ready. So basically, we have a small API in the pool object, so that GS can tell the pool to prepare pipelines for a clip that is soon to be played, so neighbors. So here now, when simply playing the pipeline, and in order to have timelines with very short clips play smoothly, we prepare only the next. So because when we are scrubbing, we prepare the clips that are just after and the clips that are before, because people just crawl around, skim around, and we needed that. And for playback, we just make sure that only the ones that are going to be played are prepared, so we can have more clips prepared for what is coming next. And then one other feature that we added this year into UI decode pool source is the notion of endpoints. So what is the first frame that you want to output from UI decode pool source, and the duration. So we basically pre-roll the pipeline, seek it as soon as possible, and so that when you have the clip need to be used, we just have it ready. Like the frame is there, the right frame is there, and we are even able to use to start seeking as soon as we get the stream collection event, so that we don't even theoretically we don't even need to pre-roll, and that's the goal, the next step, because right now we just pre-roll and then seek, but there is that possibility. I have found some bugs recently on that, but yeah. So I want to present you two case studies of users of GS. Both are basically running in the cloud. So the first one I will present is a sequence film. It builds a professional-grade, full-fledged collaborative video editing application online, so in the browser. And then we will have a look at Tella.tv, which also build a web application to record and do semi-automatic edit video online with templates and things like that, but also with quite a bit of flexibility. So this is the sequence application. I will just run some videos. So here you can see that it just like anyway. So here you can see that it's really like a complex video editing application. You have comments, you have a lot of other features. Well, just a comment. Here you can see that when you can move to having a look at a clip in the media library, that's actually all happening server side, and we just send the stream live. So that same stream, we just change it server side and all that. But no, that's not. Where is my mouse? Okay. This project has quite a few challenges. The first one is that everything runs well server side, and we need to find a clean and simple way to display the streams while we do the editing. And that all needs to happen in the browser. And this way we can take advantage of very powerful servers, and we don't need clients to be powerful at all. So we edit in the obvious solution to do the edit in the browser is just run the GS pipeline server side and send the stream over WebRTC. Then all the editing action are sent to the server. So if you want to move a clip and things like that, we just send the action to the server. The GS timeline is committed, and we have the video stream updated. And yeah, it's like the basic of a video editing application. As I was saying, all the processing happens server side. Decoding the sources also happens server side. This means that we do not have any restriction on codecs and that it can be used in the browser, even files that are not supported by web browser. Any media files that is supported by GStreamer are also supported by that application. This way we can use all the media file format that are used in the post-production industry. So during the development of that application, we discovered that some features were still missing, and we implemented them. For example, reverse playback. Well, we had some work in progress patches for that, but it was still missing. It was not upstream, it had bugs, and many elements also had bugs, so we had to fix that, and now it's properly working and upstream. We expose more properties for the mixing. We expose like many more properties in different places, and we have been working on fixing many details and bugs during the development. Then there is another project that is also heavily based on GS that is called Tella. Tella, it offers a web interface that records your camera, your desktop, etc. And it allows you to very easily create nice edited video. So complex videos, but for people that do not have video editing experience or knowledge or anything. Then you can add extra videos, add transition, add titles, etc. For that project, we had another set of challenges because the editing is not done real time, but basically faked in the browser. That means that we needed to be able to draw fancy titles, rounded corners, have smooth transition in JS. It was all kind of possible to do, but some more work had to be done to make it better and adapted for our use case. And one of the very challenging thing that we had with that project is that we wanted to render the timeline like really fast. So the idea is that as soon as the user wants to finalize the edit, the final stream should be ready almost instantly. Even if the final timeline is long. So the final stream is a dash stream. That's what we produce. And what we do is render only one or a few fragments per server. So we just divide like the processing task between many servers. And virtually, if you have a 1 minute clip, 1 minute timeline or 1 hour timeline, it's going to take the same time to be rendered. We just use both servers, right? In that image, we can see that the timeline is split every 5 seconds, which is the fragment time, and each server is responsible for rendering only its fragments. We render the fragments as CMAF using a dedicated GS CMAF mux sync element that had some logic on top of the CMF, the muxer. And that allows specifying like the fragment number, fragment duration, and just collaborates with GS so that it does the thing properly. One of the onion issue we have is that for AAC audio encoding, encoders require preloading a few samples, which is called priming. And because we start a new encoder for each segment, we had to be creative to handle those few samples that are added by each encoder. Adding a clip meta in the muxer, adding the edit boxes to let the player know that the priming was there so that you could skip it was not really an option for us because for each fragment we had that same issue. And the edit list wasn't working if you have like fragments in between that have like started a new encoder. So in the end, for audio, we essentially render a few more AAC frames before the actual part we care about, and we just end up like dropping that extra fragment, and just so that this way we are able to produce a perfect audio stream all the time. As we can see on that image, to let the server know what part it has to render, we just use nested timelines. So we create a parent timeline that creates a clip, and in that clip we will just set the endpoint and the duration of the part of the timeline that is underlying that we want to render. And this way we can encode only the fragment that we care about. So each one will have a new timeline, a source in that, an endpoint, a duration, and we render that subtimeline, exactly the fragment that we want. Well, in that project, in practice, we have 5 levels of nesting because of how everything is organized, and it makes like each scene, each thing more simple to handle afterward. So that actually brought some interesting challenges in terms of performances in NLE in particular. And thanks to the design that we have with UI decode pool source, we have been able to optimize that substantially. And in the end, we were able to have cut the rendering between last year and now by more than 100%. So now we can render like everything in 5 to 10 seconds, whatever the size of your timeline is. And well, we have been working on optimizing everything around the stack for that. And to help perfectly replicate the output of the web browser as editing, well, as I explained before, we fake the frames layout in the browser, so we have to just replicate exactly what the user was seeing when they edited the video. We ended up implementing a set of Skia-based elements to the drawing, and we make sure that, for example, GS is using the Skia compositor for layout mixing. And we have our own elements to do the drawing. Well, it's a base element, and then you can start drawing with Skia, and that makes it makes drawing much simpler than with anything else. Well, as a conclusion, I'll say that JS is mature now. It covers many different use cases, and I'm sure that many people could use JS for many new use cases that we haven't even talked about, and that they have, but they don't know that JS could be used for that. And yeah, I will be happy to hear about that. If you have any problem you think JS can be useful for, let me know. And well, in the last years, a lot of work have gone into improving JS and other GStreamer components. And most of them have already landed upstream, but there are some more upstreaming to be done for all that development to be all upstream, right? Do you have any questions? Okay, thank you.